So this is video number 3, and we left off where you were supposed to do this one on your own to see if you can come up with all the zeros. So on my screen it kind of cut off, but here's our f of x. Okay, so clearly I can see that we should have 5 total zeros because the degree of this is 5. So when I used Descartes' rule of sign, okay, I know that I get 3 or 1 positive real solutions. And then if I do f of negative x by Descartes' rule of sign, I know that I should have 1 negative real solution. Okay, so I started with my positive real because it's 3 or 1. I'm guaranteed 1, but it may be 3. So I checked 1. Okay, 1 didn't have a remainder of 0, so I knew that wasn't a factor. So then I checked 2. I got a remainder of 2, so x minus 2 is a factor. Okay, I first noticed that I first pulled out an x here because x is my greatest common factor. Okay, so when I pulled out an x, I have x and then all this here. Okay, now when 2 is a 0, that means x minus 2 is a factor. And then I have this is my, I guess, leftovers, which I get from here. Okay, and then I can use grouping with this number, so that's how I got this. Okay, so my function in fully factored form, okay, is right here. Okay, now that it's fully factored, I can pull out my zeros. So from this x, I just get x equals 0. X minus 2, I get x is 2. X plus 3, I get x is negative 3. And the x squared plus 1, okay, my work is right here. If I set that equal to 0 and solve, I get plus or minus I. So I wrote them all out right here. And notice I do have the 5 total zeros right here. So hopefully this is what you got. All right, so let's look at example 2 now, okay? But before we look at example 2, let's look at the complex conjugates theorem, and this was covered in that packet that we did, okay? So it just says that if a plus bi, meaning that it's an imaginary solution, is a 0, then a minus bi also has to be a solution. So we should know by now that imaginary solutions come in pairs, so this should not be a big surprise. Okay, so if I look at example 2, it says write a polynomial function of least degree that has rational coefficients and a leading coefficient of 1. Okay, and I know the zeros are going to be 2 and 3 plus I. Okay, well, guys, if 3 plus I is a solution, I know that 3 minus I is also a solution. Okay, so in other words, the minimum number of zeros I can have is 1, 2, 3. 3 zeros. And so when it says of least degree, that just means that we want the degree of this function to be 3 as well. Okay, we're not going to add any more zeros. We're not going to do more than we have to do. Okay, so what I'm going to do is I'm going to create a function, so f of x equals, now remember, if 2 is a 0, x minus 2 is a factor. Okay, well, the same concept. If 3 plus I is a 0, that means x minus 3 plus I is a factor. And if 3 minus I is a 0, that means x minus, parentheses, 3 minus I is a factor. Okay, now I can have an a right here, but when it says leading coefficient of 1, that just means my a is 1. So if you want to put a 1 there, you can, or you can just keep it like this. All right, so I'm just going to rewrite this and clean this up a little. This is x minus 2. This is x, and we have to distribute this minus sign, so x minus 3 minus I, and then x minus 3 plus I is over here. Okay, so now it's just a matter of multiplying it out. Okay, I'm going to multiply these two first to clean up all the ugly stuff that goes on. Okay, and I like to use the box. So I have a 3 by 3. So I have x minus 3 minus I and x minus 3 plus I. Okay, and then I look at an area model. So x times x is x squared. This is minus 3x, and this is minus xi, minus 3x, plus 9, plus 3i, plus xi, minus 3i and minus I squared. Okay, now remember, after we have all these boxes, I know there's 9 of them, I'm going to add them all together. Okay, but the good thing about doing this, and there's a reason I picked these two to do first, it's because all the ugly stuff cancels out. Okay, so notice we have minus xi and a plus xi, so those cancel each other out. Okay, we have a minus 3i and a plus 3i, so those cancel each other out. So notice I'm not left with any imaginary stuff anymore. Okay, now remember, I squared is -1. So a negative I squared would be a negative -1, which is just a positive 1. So this is just a 1. Okay, so if I add all these terms, I get x squared minus 3x and a minus 3x is a minus 6x. And then a plus 9 and a plus 1 is a plus 10. Okay, so this right here, if I multiply them together, turns into something that looks very normal. X squared minus 6x plus 10. Okay, now don't forget, I still have this x minus 2 up front. Okay, so now I'm going to do the same thing. I'm just going to multiply these. So we have a 2 by 3, so x minus 2, and then we have an x squared minus 6x plus 10. Okay, so this would be x cubed minus 6x squared plus 10x minus 2x squared plus 12x, and then a minus 20. Okay, so if I add them all up, I get, well, there's just a single x cubed, so x cubed. Okay, a minus 6x squared and a minus 2x squared gives me a minus 8x squared. Plus 10x and plus 12x gives me a plus 22x, and then minus 20. So this will be my final answer. All right, so let's look at example 3 now. It says a tachometer, I hope I'm saying that right, I don't know, measures the speed in revolutions per minute at which an engine shaft rotates. For a certain boat, the speed, which is x, is in hundreds of RPMs, okay, of the engine shaft, and the speed s in miles per hour of the boat are modeled by here. Okay, so we have 2 different speeds, which I don't understand engines, so that's a little confusing, but we can get over that. Okay, so what is the tachometer reading when the boat travels 15 miles per hour? All right, so when I'm reading this, like I said, I don't know anything about engines and I'm already confused. Okay, what I need to know mathematically though is if this 15, what speed does that talk about? Is it talking about the speed in S or the speed in X? Okay, well, notice my X is in hundreds of RPMs and my S is in miles per hour. Okay, so if this is in miles per hour, this must mean my S is equal to 15. Okay, so I'm going to plug that into this equation. So 15 equals 0.00547 x cubed minus 0.225 x squared plus 3.62x minus 11. Okay, now, guys, we are not even going to try to factor when these are decimals, okay? Unless they're like really, really nice decimals and we can manipulate it a little bit, okay? We're not even going to do that. So we're just going to go straight to our graphing calculator, okay? So pull out your graphing calculator. Okay, the first thing you want to do is you want to put the equation on the right-hand side, so just this equation here that I highlighted in green, into your first y equals. Okay, so I kind of cheated and I already had that done. Okay, the second thing you want to do, okay, is you want to put your 15 in the other one. Okay, so we're actually going to graph 2 graphs. Okay, so we're going to put 15 in right here. Okay, now I'm going to graph it. I might have to adjust it. Ooh, my window is way crazy. Let's just start with a standard window, and then we can adjust as needed. Yep, we want to zoom out. zoom out. Okay, so we should know right now that the solution to this equation is right here where these two lines intersect. Okay, now I know a lot of you love this trace feature. I hate it. Okay, there's other ways around it to get a lot more accurate answer. So what we want to find is the intersection of these two lines. Okay, so I can find that if I go to second and then trace, above it is calculate, and I want to calculate that intersection. Okay, now it's going to show me each curve. I want to kind of narrow down about where that intersection is because sometimes these intersect at more than one spot. Okay, this one doesn't. So about there, and I'm going to hit enter. Okay, then I know it's hard to tell, but it switched me to my second curve. And once again, I want to get pretty close to that intersection. I'm just trying to tell my calculator where to narrow it down. I'm going to hit enter again. Guess, I don't know why they put guess. Okay, there's my intersection. So we knew my y would be 15, but my intersection is when x equals 19.863. So if I can go back here and I can say my x is about 19.863. Okay, now we're not done yet because we need to clean this up a little bit more. Okay, so what we found is our x, and our x is in hundreds of RPMs. So I can just go in right here, hundreds of RPMs. Okay, now hundreds of RPMs, that sounds like disgusting. So if I multiply this by 100, that would give us how many RPMs? So like, think of it as like 1900. Okay, so to multiply by 100, guys, just like we do kind of in a percent, we just move this decimal. So I could say at about 1986, because I multiplied by hundreds, now I got rid of that hundreds, RPMs. And that will be my final answer. Okay, so here's to monitoring progress, guys. I would encourage you to at least do this one because we didn't have a practice on your own, and this one's easier than the first one we did. So I'd at least do two, but I would do both of these and then check your answer. So if you pause this, okay, work these both out and then come back, I'll have them worked out for you so you can check yourself. All right, so hopefully you took the time to do these on your own. Okay, so on this first one here, I have for sure one positive real solution, and then my f of negative x, I have either two or no negative real solutions. Okay, so me, I'm just not a risk taker. I wanted to find my one positive real solution first. So I checked for one, didn't have a remainder of 0, checked for 2 next, and it worked. Okay, so my only one positive real solution is x equals 2, which means x minus 2 is a factor. Okay, when I get this part here, this part here comes from what's left over. Okay, so now I want to factor this more, but I want to just worry about factoring this. Okay, remember I only had one positive real solution, or notice there's no sign changes in this, so you know there's no more positive real solutions. So now I want to check for my negative real solutions. Okay, well, the first negative real solutions I checked was -1. I always start small and go big. In this time, it worked out in my favor because I had a remainder of 0. Okay, so if -1 is a 0, then that means x plus 1 is a factor. Okay, and then I'm left with this here, which is that. Okay, now that factors by grouping, so my work is right here in red. So x plus 1, x squared plus 4. So in fully factored form, guys, this is my function in fully factored form. Okay, and then I do have 5 zeros. Now notice my -1 has a multiplicity of 2, okay, because it's squared. So when I list that, I have to list my -1 twice. Okay, so my zeros are 2, -1, -1, 2i, and -2i. My two imaginary solutions, guys, comes from this, and my work for that is down here. Okay, and then here is the solution to number 2.